Hello guys, in this video I'm going to show how to solve minimum difference element. So given an array of numbers sorted in ascending order, find the element in the array that has minimum difference with the given key. So the functions takes in sorted array, right? And a key sorted array, think of binary search, right? But here we're not required to find the exact number, right? But the number with minimum difference with the key. So how to solve this problem? Let's try to run through these examples. We have this given sorted array ascending order. What is the number with a minimum difference with 12? It is clear that 12 will be between 10 and 15, right? So we can using binary search to find if we use binary search, we kind of like if we use binary search, we will have two pointers, right, left and right, and the number left will kind of we will have the left and right is a kind of like two bounds of the number that we're looking for, right? So by doing binary search, um, we kind of like make the um, the limit left and right smaller, right? So until if we cannot find exact match, we probably gonna exit the iterations, the loop, right? When the number left is no longer uh, the number left is no longer less than or equal to number on the right. So that is when the key is sitting between these two, right? Sitting between left and right, right? So so we can so it's obviously that we have only two possibilities, right? Which is either left or right. So uh, for that case, we can just check if it's not left, then we return right, or it's not right, return left, right? So that is the basic idea. So let's run manually to this given input. We have left here, we have right, right? So okay, we find the middle, which the middle numbers, right? Which is 8 here. Compare 8 with the key. Uh, 12 is greater than 8, so it should be on the right. So I will update the left to the right. The left is the number right after the middle, right? So we kind of lower our limit down, right? So now our key will sit in between left and right, right? Again, what is the middle of left and right? It is left, right? For this case, right? So we compare 12 with middle, so it's greater. So it should be on the right of the middle. So we will again reassign the left, right? Which is the number right after the middle here. So left right now is at 15. Again, we will compare 12 with 15. So now 12 is less than 15. So sorry, we need to find the middle first, right? Middle of left and right here is the same. So 12 is less than the middle, so it should be on the left of the middle. So I will update the right. So the right now is the number that right before the middle, which is 10. So now you can see that right is no longer number right is no longer greater than number left. So we exit the loop, and as we expected, right? The key is now sitting between left and right. So we just need to check, right? Check the difference of the key with left and right. Okay, so let's code it down. So binary search left and right. Left equal to 0, right equal to array of length minus 1, which is the index, right, of the last number. Okay, so as long as what? As long as number at left is still no. As long as left is still less than or equal to right, then I want to jump in this loop. Inside here, just like every binary search problem, we need middle. Middle here, left plus right. We try to calculate the middle of left and right. So here is one way, right, to avoid overflow, or you can just like left plus right divide by 2. But here we are a little bit careful with overflow floor. Okay, so the middle, I will check if key, how many cases? Key equal to middle, array the number at middle, right? So we have an exact match here. So the difference is 0, right? So we have a so we can't find a number with smaller difference. So here we can return the key, right? Or the array at middle is the same here. So else, if key greater than array at middle, it means it's on the right middle. So I need to limit again, which is I will reassign the left to middle plus 1, or else it is when key is less than the array middle, so it's on the left. So I will reassign the right pointer. Okay, the right will be middle -1. We exit when the left is greater than right. So now there are two cases, right? We need to we need to compare compare what? Compare the difference of the key with number up left or and number right. So key minus number left is array left, right? We need the absolute value instead, and the difference between key and the number right. Okay, so if the difference at left is less than, I will return array at left, else I will return array at right. Okay, just 11 5. Okay, okay, so it works, right? Just to make sure. Okay, so that is it for this problem. Minimum difference element in a sorted array using binary search, a modified version of binary search. So that is it for this video. Thanks for watching. See you in the next one. Goodbye.